The next two sections are formula-based sections. You're going to be given equations or formulas for these. Okay. Both of them are useful formulas for non-right triangles. Okay. A non-right triangle is called an oblique triangle. Okay, now, it doesn't mean you can't use these for right triangles, and many of you do or will. My students always tend to use this. Like once we go through them, they'll use it for everything. Okay, but there's no reason to use these more complex formulas for right triangles because the trig ratios are already more simple. It's a simpler way to approach a right triangle problem than either law of sines or law of cosines. And so if you see a problem involving a right triangle, my suggestion is look to use Pythagorean theorem first. That's easy. And then trig ratios, just SOHCAHTOA. If you see a non-right triangle, then you're going to look to use the law of sines or law of cosines, depending on the pattern of information that's used in the problem. All right, so let's talk about law of sines. There's two main scenarios. To use the law of sines. Okay, and those scenarios are patterns of ASA and AAS. Okay, now there's an additional scenario that we would use this, and that's SSA. We'll talk about that here in a little bit if there's time. Okay, but the two I want to focus on for right now are ASA and AAS. Okay, so what this means is if you're given a triangle, so let's say you have triangle ABC, okay, and here when I'm working on these, lowercase a, b, and c represent the sides opposite the angles with the same letter. Okay, but if you're given two angles and one side in a triangle like this, so let's say you were given an angle of 23 degrees and an angle of 57 degrees. And then you were given the length of a side. And what you want to do is you want to see what pattern of information is provided here. So you have these two angles. Is the side opposite one of the angles, or is it contained between the two of them? Two angles and the side is between them. It's not opposite, right? So that's an example of ASA. And now, if you took and you had information in which, again, let's say we took the same angle, so 57, 23, but in this time the side was opposite one of these angles. Now, so this is an ASA pattern. This pattern of information is two angles, and now is the side between the two angles, or is it opposite one of the angles? Now it's opposite. So this is a pattern of ASA, or I'm sorry, AAS. Okay, and then finally, if we can come over here, what we'll talk about a little bit later, and that is if you have information where you're given an angle, so let's say 57 degrees here, and you're given two sides, 12 and 10. Okay, this is a pattern of SSA. You have two sides, and one of the angle is opposite one of those sides, so this would be a pattern of SSA. All right, so the first step in solving any problem that will involve a law of sines is to identify what the pattern is, because the pattern dictates what type of equations you use. So AAS or ASA, you use law of sines. SSA, you use law of sines. And then, does anybody recognize these two patterns as being part of another category? You guys recognize these from geometry? They're called what? You remember? Congruence patterns. Okay, so there's two other congruence patterns. beside these two? Anybody remember what those are? Here. Okay, so side, side, side is one. The angle, angle, angle is a similarity pattern. Okay, so there's one other. There's SSS and so SSA is this one. The reason I set this aside is this is not a congruence pattern, and and you'll see why when we go through these examples. There's one other pattern though. So that's the same one. This is just it written the other way around. ASS. I write it SSA for obvious reasons. Yeah. All right. One last pattern. SAS. So there's SSS, SAS. And then ASA and AAS. Those are the four congruence patterns. And the two that involve the two sides, the SSS and SAS, are going to be used in the next section, the law of cosines. And so you need to identify: are we dealing with one of these patterns? If so, we're going to apply the law of sines. And here's what the law of sines states. It says that the ratio of a side of an angle to the sine of the angle opposite that side, so A over the sine of A, is equal for all pairs of sides and opposite angles. So that's equal to B over the sine of B. We could also say that's equal to C over the sine of C. Now, you're not going to actually have all three of these in a problem. You're just going to choose two of them and set them equal and relate them. And now the other way to think of this, so I would use this relationship here. When you're solving for an unknown side. Okay, there's another way that you can apply these, and that is just flip the fractions. So this is equivalent to saying that the sine of any angle A over the side opposite that angle is the same, again, across the board for any triangle. So it equals the sine of B over B, which is also equal to the sine of C over C, where C is the side opposite that angle. And again, what I would use this for is when solving for an angle. Now, the reason I would choose these, and you can use either one, but I would put the unknown or the variable that I'm solving for in the numerator. It just makes it easier to solve the equation. And so if I'm solving for side, I'm going to put the side in the numerator. If I'm solving for an angle, I'm going to put the angle in the numerator. And again, just to kind of give a heads up, this pattern right here is probably going to be used for ASA and AAS. This pattern right here is probably going to be used for SSA. Right? As far as the first one that you use. The SSA one, we're actually going to use both of these. But in this top pattern, we're not going to use this form.